Hello students, welcome back. In the previous class, we learned how to find rational numbers between two given rational numbers. So I'm going to tick this off, okay. Now let us go ahead and go through the points to remember for real numbers. So for real numbers, the points to remember, first one is that every real number is either rational or irrational. So every real number is either rational or irrational, right? The second point is that there exists infinite number of real numbers between any two given real numbers, okay? So there exists infinite number of real numbers between any two given or any two real numbers, right? And the third point, every real number can be plotted on your number line, which is why the number line is also known as the real line or the number line, okay? So every real number can be plotted on the number line, okay, which is why the number line is also known as the real line, also known as real line, okay. So we have seen points to remember for real numbers. Now let us quickly go ahead and solve exercise 2.1 of your chapter number system, okay. I'll erase the board for now. Exercise 1.1. I'm sorry I mentioned 2.1, it was exercise 1.1. How can I forget? It's the first chapter. So this is on page 5. Question 1. Is 0 a rational number? Can you write it in the form P upon Q, where P and Q are integers and Q is not equal to 0, okay? So is 0 a rational number? Can you write it in the form P upon Q, where P and Q are integers, Z is for integers and Q is not equal to 0. So what do you think? Yes, 0 is a rational number. So I'll say my answer, yes, 0 is a rational number. Why? Because 0 can be represented as 0 upon 1, for example, right? So where 0 and 1 are integers and 1 is not equal to 0, right? Where 0 and 1 are integers and 1 is not equal to 0, right? I can even write 0 as 0 upon minus 1, right? Where 0 and minus 1 are integers and minus 1 is not equal to 0. So I could replace this with 2, 3, 4, minus 1, minus 2, minus 3, minus 4 and so on, right? Second one, find 6 rational numbers between 3 and 4. So we are going to follow both the methods that we learnt in our previous class to find 6 rational numbers between 3 and 4. So solution, method 1, right? So I'll say let my x be equal to 3 and y be equal to 4, right? The rational numbers between 3 and 4 can be found using the formula x plus y upon 2, right? So let's take x as y, x is 3 and y as 4, right? Our rational number is going to be 3 plus 4 upon 2, which is equal to 7 upon 2, right? Now let's take x is equal to 3 and y is equal to 7 upon 2, right? So I'm taking x as 3 and y as 7 upon 2. So what do I get? 3 plus 7 upon 2 upon 2, which is nothing but LCM for 3 upon 1 and 7 upon 2 is 2. So I'm going to multiply my numerator and denominator over here with 2. So this becomes 3 2s are 6 plus 7 upon 2 into 2, which is 13 upon 4, right? Now I'm going to take my x as 4 and y as 7 upon 2, okay? So what does this become? 4 upon 1 plus 7 upon 2 upon 2. So the LCM is 2 over here. This becomes 4 2s are 8 plus 7 upon 2 into 2. 8 plus 7 is 15 upon 4, right? I have found 3 numbers. I need to find 3 more numbers. So I'll take x is equal to 7 upon 2 and y is equal to 13 upon 4, right? So what do I get? 7 upon 2 plus 13 upon 4 upon 2. Now the LCM here is 4. So I'm going to multiply the numerator and denominator here by 2. What do I get? 7 2s are 14 plus 13 upon 4 into 2. 14 plus 3 is 14 plus 13. 14 plus 13 is 27 upon 8, right? So now I'm going to take 13 upon 4 and 15 upon 4 as x and y. So x is equal to 15 upon 4 and y is equal to 13 upon 4. What do I get? 15 upon 4 plus 13 upon 4 upon 2, right? So this is 28 upon 4 into 2, which is 4 1s are 4, 4 7s are 28, 7 upon 2. But here these two values are the same, so I'm just going to erase this and take a different combination. How about 7 upon 2 and 15 upon 4? X is equal to 7 upon 2 and y is equal to 15 upon 4. Let's check. What do I get? 7 upon 2 plus 15 upon 4 upon 2. The LCM here is 4. So I'm going to multiply this by 2, right? So 14 plus 15 upon 4 into 2, which is 29 upon 8, right? 1, 2, 3, 4, 5. I need to find one more number. So I'll take my x as 15 upon 4 and y as 27 upon 8, right? So what do I get? 15 upon 4 plus 27 upon 8 upon 2. This is 8. Okay, here the LCM is 8, so I'm going to multiply the numerator and denominator by 2. So I get 30 plus 27 upon 8 into 2, which is 57 upon 16. Therefore, my 5 rational numbers are 7 upon 2, 13 upon 4, 15 upon 4, 27 upon 8, 29 upon 8 and 57 upon 16. 6 rational numbers, not 5, between 3 and 4. Okay. We will take a look at method 2. So, method 2. So, what do we do in method 2? We take 2 rational numbers which are given. I will say let x be equal to 3 and y be equal to 4, right? So, we notice that y is greater than x. Therefore, we need to find a digit d which is the difference. Okay, we need to find a number d which is the difference given by y minus x upon n plus 1. Now, we know what y and x are, right? So, what is n? N is the number of rational numbers that we need to find, which is 6. So, d is nothing but 4 minus 3 upon 6 plus 1, which is 1 upon 7. Now, we also know that by the second method, these rational numbers that we need to find are as follows. Therefore, the 6 rational numbers between 3 and 4 are here: x plus d, x plus 2d, x plus 3d, x plus 4d, x plus 5d and x plus 6d. Why until 6d? Because we need to find 6 of them. So, 1, 2, 3, 4, 5, 6. But the sum doesn't end here. We have to solve this further. Okay. So, this is what? X is 3. So, I substitute 3 and d is 1 upon 7. So, 1 upon 7. Now, the LCM, 3 can be written as 3 upon 1. So, the LCM here is 7. Therefore, what do I get? I multiply this by 7 and this by 7, right? So, I get 21 plus 1 upon 7, which is 22 upon 7, right? So, I start writing here 22 upon 7, right? Let us find the second one. You have x plus 2d. So, this is equal to 3 plus 2 into 1 upon 7. So, similarly following the LCM method, what do I get? 7 3s are 21 plus 2 upon 7, which is 23 upon 7, right? Now, x plus 3d, this is equal to 3 plus 3 into 1 upon 7. So, 21 plus 3 upon 7, which is 24 upon 7. So, in this way you will notice that, see, this is 22 upon 7, 23 upon 7, 24 upon 7. So, this will be 25 upon 7, 26 upon 7 and 27 upon 7. But let us just find it out. Okay. So, this is going to be 3 plus 4 into 1 upon 7. So, 21 plus 5 upon 7, 21 plus 4 upon 7, which is 25 upon 7, right? So, 23 upon 7, 24 upon 7, 25 upon 7, okay? And 3 plus 5 into 1 upon 7, which is 21 plus 5 upon 7, which is 26 upon 7. And finally, the last one, 3 plus 6 into 1 upon 7, which is 21 plus 6 upon 7, which is 27 upon 7. Thus, we have found 6 rational numbers between 3 and 4 by using method 2, which is the one-step method of finding all rational numbers between 2 given rational numbers. Not all rational numbers, but n number of rational numbers between any 2 given rational numbers. Okay, we will go ahead and solve the third question. So, my third question, you have to find 5 rational numbers between 3 upon 5 and 4 upon 5. Okay. 5 rational numbers between 3 upon 5 and 4 upon 5. I'll see solution. Now obviously, just like me, you must have observed that the first method, that is x plus y upon 2, using that it was very tricky. Sometimes it can get really tricky and time consuming to find the rational numbers. Now we have fractions, so that is going to become very tricky. So we'll pick up very simple methods to do this. So let's take a look at the second method itself, which is the one-step method. You can solve in your exams using any of the methods, just that you should find valid rational numbers between two given numbers. So I'm going to take the second method, that is the one-step method, right? So I'm going to say let x be equal to 3 upon 5 and y be equal to 4 upon 5, right? Now my y is greater than x, right? Therefore I need to find a number d, which is the difference, such that d is equal to y minus x upon n plus 1. N is the number of rational numbers that I need to find, so n becomes 5. Right. So this is equal to 4 upon 5 minus 3 upon 5 upon 5 plus 1. This is 1 upon 5 upon 6, which is nothing but 1 upon 30. Right. So my d is 1 upon 30. Therefore my 5 rational numbers would be, the 5 rational numbers are x plus d, x plus 2d, x plus 3d, x plus 4d and x plus 5d, right? So let's go ahead and substitute the value of x and d to find the 5 rational numbers. So my x is 3 upon 5 plus 1 upon 30. Now the LCM of 5 and 30, 5 ones are 5, 5 six are 30 and 6 ones are. So the LCM is 30, therefore I multiply the numerator and denominator of my first term by 6. So what do I get? 3 6 are 18 plus 1 upon 13, which is 19 upon 30, right? Similarly, x plus 2d, so this is 3 upon 5 plus 2 into 1 upon 30, right? So this is going to be 18 plus 2 upon 30, which is 20 upon 30. Similarly, you will notice that these terms, the remaining terms are going to be, see, the difference between the numerators is 1 over here. So the other terms will be 21 upon 30, 22 upon 30, 23 upon 30, 24 upon 30, okay? So, however, let's just go and solve this further. This is equal to 3 upon 5 plus 3 into 1 upon 30. So, this is 18 plus 3 upon 30, which is 21 upon 30. Then you have 3 upon 5 plus 4 into 1 upon 30, which is 18 plus 4 upon 30. So 18 plus 4 is 22 upon 30, right? And finally you have 3 upon 5 plus 5 into 1 upon 30. This is going to be 18 plus 5 upon 30, which is 23 upon 30, right? So I have got my 5 terms, 1, 2, 3, 4, 5. Now if you see the next term, if you follow this fashion, you would get a 24 upon 30, but 24 upon 30 you can divide it, right? You have 24 upon 30, 6 4s are 24, 6 5s are 30, which is 4 upon 5, okay? That is why we use this method, and y minus x upon n plus 1 is equal to d, right? So my numbers are 5 rational numbers between 4 upon 5, 3 upon 5, and 4 upon 5 are 19 upon 30, 20 upon 30, 21 upon 30, 22 upon 30, and 23 upon 30. So we have solved our third question. Let us go ahead and solve the fourth question. We are on the last question of this exercise, and we need to state whether the following statements are true or false. We will also give reasons for the same. So for the first one, every natural number is a whole number. What do you think? Yes, every natural number is a whole number because whole number comprises of 0 as well as all the natural numbers. So I am going to say that this statement is true because whole numbers comprise of 0 and all natural numbers. Right? Every integer is a whole number. This is a false statement. Why? Because integers have negative numbers, whereas whole numbers are only from 0 to positive infinity. That is 0, 1, 2, 3 and all the positive numbers. So this statement is false, and you just need to give an example. Let's say because integers such as -3, -2, -1 are not whole numbers. Right? And finally, every rational number is a whole number. So every whole number is a rational number, but every rational number is not a whole number, because rational numbers are expressed in the form P upon Q, where Q is not equal to 0. So if I take into consideration this example, 2 upon 3 is another example for a rational number, but this is not a whole number, right? Because whole number consists of 0 and all the counting numbers, that is natural numbers. Obviously, this doesn't fall into that category. So, I am going to say this statement is false because rational number such as 2 upon 3 is not a whole number. Right? Please take a look at the questions. So with this we wind up exercise 1.1 of number system, and I hope your concepts are clear with regards to real numbers, rational numbers, irrational numbers, whole numbers and natural numbers as well as integers. We will continue with the rest of the chapter in the forthcoming classes. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.